Let's solve homework exercise number 22 from section 10.2. We have construction costs are $145,000 per kilometer. Find the cost of the building a new road in the figure shown. Okay, again, we have a right triangle because we're given the square here, so we know it's a right angle. And so now what I'm going to do is actually it's per kilometer, so what we can do to make the number smaller is we could just go ahead and convert. Remember, kilo, hecta, deca, and the unit by itself is meters. So if we go from meters, 1, 2, 3 jumps to get to kilometers, so 36,000 meters is going to be 1, 2, 3, 36 kilometers. And 15,000 meters, again, 1, 2, 3 jumps, will be 15 kilometers. We need to find the length of the new road. Now, the right angle is here. The new road is opposite the right angle, so it is the hypotenuse. Okay, so using the Pythagorean theorem, okay, we have c squared equals a squared plus b squared. Okay, my new road is x, whatever, or you can use whatever variable you want, is equal to 36 squared plus 15 squared. Okay, now 36 squared I did on my calculator. 36 squared is 1,296. 15 squared, I know, is 225. So if we add those two numbers together, okay, 1296 and 225 is going to give us 1,521. So now we have x squared, right, on the left side equals 1296 plus 225 is 1,521. And then we're going to take the square root, so that the square root of x squared is x, is equal to the square root of 1,521, and that will give us the length of the road in kilometers, okay? And then, okay, now, once we get the length in kilometers, we'll do it on our calculator, we have to multiply by what? 145,000 times the number, because it's per kilometer, to find the cost of the building. So we have one more step. After we get this answer, we're going to multiply by 145,000, because that's the cost of each kilometer. Okay, so we'll do the rest on our calculator. So we'll go ahead and do, okay, second square root, I believe it was 1,521, okay, which exactly comes out to 39. And then we said we're going to multiply by each kilometer is 145,000. There it is. So the total cost is going to be $5,655,000. Okay, there it is. Okay. Again, that last step, we got the length of the new road is 39 kilometers from the Pythagorean theorem, and then the cost is 145 per kilometer, so we took the 39 times 145,000 to get the answer, 5,655,000. Okay? Very good. Okay, we need to find the length of the side AB, okay, all the way from A to B. What we're going to do is we're going to split it up into two triangles. The triangle, we're going to go from A to, we'll call point C, and then we'll go from A, some C to B. So notice the triangle on the left. There's our right angle. We call this point C. This is 15 feet, and this is 12 feet. So what we need to do is find the length of AC. We'll call it whatever, X. Now again, opposite, here's the right angle in the right triangle right here. Opposite the right angle is the 15, so that's the hypotenuse. So again, using the Pythagorean theorem, we've got 15 as a hypotenuse, so 15 squared is equal to x squared plus 12 squared, the two legs. 15 squared is 225. X squared, 12 times 12 is 144. So we're going to subtract 144 from both sides, and we're going to get 81. So x squared equals 81. Take the square root of both sides. Square root of x squared is x. Square root of 81 is a perfect square, right? Because 9 times 9 is 81. So that means x equals 9. So from A to C is 9, right? There's the 1, okay? Now we got to go with the other triangle. Same idea to go from C to B, okay? So that's 9. Now we'll go ahead and look at the other triangle. So this one we have, well, let's just close. I'll just close the ink layer. Okay, and we'll remember that was 9, right? From what we did from point C is 9. Now the other triangle is what? Here's my point C. This is the 12, right? Here's the right angle. This is 20, and from C to B, again, we'll just call x, right? And again, now here's the right angle. Opposite the right angle is a 20, so that's the hypotenuse. So by the Pythagorean theorem, 20 squared is equal to x squared from C to B plus 12 squared. Okay, 20 squared, 20 times 20 is 400. 12 squared is 144. If we subtract 144 from both sides, we get 256 equals x squared. Take the square root of both sides. Square root of x squared is x. Square root of 256, if you do it on your calculator, is 16. Again, second x squared, and then you'll get this radical square root, put in 256, and you'll get 16. Now notice, what's the length of AB? AB goes from what? A to C is 9, from C to B is 16, so 16 plus 9 is equal to 25. Okay, so again, we broke it up into two right triangles, and we found the leg of this right triangle, and then we found this leg of this right triangle, and these two legs gave us the total length, added them to get the length of AB. So length AB is 25, and everything is in feet. All right, very good. Okay, find the length of the side of the right triangle. Problem number 24. Again, right triangle, we've got two sides. We can apply the Pythagorean theorem. Here's the right angle, so the 68's opposite away from the right angle. That's the hypotenuse, right? And the two sides that form the right angle are the two bases. So that's the A and the B. So the setup is the hypotenuse is by itself. 68 squared is equal to A squared plus 60 squared. And we got to solve for A, which will be the length of that side. Okay, we'll go ahead and do 68 and 60 squared on our calculator to get those values. 68 squared is 4,624. 60 squared is 3,600. So now again, remember what we had. The hypotenuse away from the right angle was 68 squared is equal to A squared plus 60 squared. 68 squared we just did on the calculator, 4,624 equals A squared plus 60 squared is 3,600. Subtract 3,600 from both sides. Okay, these cancel, and we get 1,024 equals A squared. If we take the square root of both sides, we get the square root of a squared is equal to a, so a is the square root of 1,024. Again, we'll do second x squared to get the square root, and then we'll put in 1,024, and we will, type exact answers. Okay, let's go ahead and see if this is a perfect square, because it's exact answers. So we'll go ahead and do second radical 1,024. And yeah, it is a perfect square. So again, since it's a perfect square, you just go ahead and put in 32. If your problem has different numbers, then you might have to break down the radical. But this was a perfect square, so 32 was indeed the correct answer. Okay, we're going to stop this session here at number 24. If you have any questions, send me an email at tsquares@hodges.edu or call me at 239-938-7805. Thank you.